Hi folks, it's been a long time since I posted anything on my site. I don't know, it's just you kind of run out of ideas, but just thought that I would cover something which nobody seems to have covered in great detail apart from Thread Express, who's done some great videos on this. But I have the Series 3 PCNC 1100, the Tormac, and I use it extensively for various bits and pieces. And I also bought Rapid Turn when it first came out. I did have the predecessor to it, which was relatively useless, to say well, I wouldn't say useless, but it didn't have any guts to it. At least the Rapid Turn has got some strength to it, some power to it. The shortcomings of the Rapid Turn are the tooling method. One small tool holder mounted to the spindle, which is locked in position, is not that good because it doesn't release the true potential of the Rapid Turn, and you do need, in my opinion, some gang tooling to make it effective. Thread Express has done this, he's done a great job on it, and that's where I got my ideas from. But I took my time and I made some tooling to go with the Rapid Turn, which I'll show you and give you a quick idea of what it looks like. But one of the things I wanted to cover was the method of programming the Rapid Turn to move around between tools, because nobody seems to have covered that, and it had me baffled for a while as to what I had to do. But anyway, I'll go through that with you. But this is the sort of part that I'm making. I'll show you that. Okay, these are the parts I've been asked to make. They're wheel nuts for 1920s to 1930 Humber motor cars. Quite a well-known make in the day, quite a sort of reasonable mark. These are made from some kind of hardened bronze or a brass and then nickel plated, but you can see they take a bit of wear, they're getting a bit tattered, so I was asked to make some in 316 stainless. And this is where, you know, the Rapid Turns come in really good. Finish is, I can't complain at all about that. It's absolutely fabulous finish, and it's quite good. I would have tried tapping on here, but I didn't fancy it. Don't know how good my tooling is, you know, don't know how much torque this can take, but I think it's pretty good. It still works. The tapping I do by hand on these, but I'll show you I'll show you the setup. As you can see, I've got a load of blocks hung off these plates that are attached to the mill. If I give you an idea, again, it's similar to Thread Express's idea, where I've drilled and tapped into here, and I've given myself a nice box structure. This structure here, nice box shape to give lots of rigidity to here. I use some longer bolts in here on the nose of the spindle, because you know you can take them out and push them through the holes in here, so that holds it all together. The holes are all spaced here. This is a bit of a waste because it's too far over in the y-axis, but I'll think of something one day. I might even put a plate underneath here to take tooling, but I'm quite happy with what I've got so far. As you can see, these are the hangers. 1, 2, 3, 4 hangers there, and one hanger has the two drilling sizes. One's a clearance hole, the other's a tapping hole, and a centre drill. And there we have our parting tool with a coolant hose on it. And one thing I did find with 316, don't try to part it with mist coolant. It will just wreck tools. You need flood coolant. And also in there, you can barely see, but yeah, you can just see it, right hand facing tool and a left hand facing tool. So that's the setup there. And of course there we have the Rapid Turn. My Rapid Turn I fitted a lever collet closer to, because if you're doing repetitive work, it's a pain having to use that little Tommy bar that comes with it, a toggle. Also I've got a hexagonal collet for holding the work. And this is about as big as you can get, I think. It's good though, it does the job. So anyway, I'll mount the camera, try and avoid shake, Before we go into a great deal of filming of the component being made, one of the things you need to do when you're setting up the tools, obviously, let's take a look. You have to be very careful where all of these go. Hence, all of these longer components are clear in the y-axis of here, and also in the z-axis that this won't collide with this. And you can see I've got quite a bit of overhang here, given that the component is this long. However, you need that to clear the work, otherwise you will end up having crashes, and crashes aren't nice. I have had a few in my time, and it just sickens you. You know, there's a lot of money in tip tooling and so on, and you can break it just like that with these things. So first of all, make sure that your Z-axes are clear, and also what you need to do is center all of these on the 0 point, which is the center with the center of the spindle, and take a note of the reading in the y-axis, because that's very important. Now, what I did when I set this program up, you will see on here my list of Y positions for each tool that's in here, complete with mistakes there. T2 is 61.978, couldn't figure it out at first. Y, T6 is 15.04. You don't really need to put those in the offsets table here. You'll see I've got nothing in the y-axis at all. However, I think you could reference them, but I don't see any point. It's very easy to do things the way I'll show you. So make a note of the center positions, the Y value, and obviously your X and Y you will do as you would normally. In making this video, I'm trying to explain to the relative novices of CNC machining, especially those that have got the Tormac with the rapid turn attachment, how you set up the lathe, how you set the lathe attachment up to do a bit more useful work than just with the single tool holder that comes as more or less standard with it. As you can see from my machine, I've made my own gang tooling. It was a relatively simple task because I did it all on the Tormac anyway, and fitting it up was pretty straightforward too. One of the problems you have to be very careful of collisions. Any of the longer articles, you have to make sure that they clear either the front face of the lathe attachment or pass by the side of it, which you probably see in the video. The drills or the longest parts, they're all kept well outside to the outermost side of the y-axis. The nearest tool is actually too close to the limit switch on the y-axis towards the column, but I got around that by actually putting the tool in at a slightly different angle, and it's not sat in the holder vertically, it's slightly off vertical. That gives me those few vital thousandths of an inch, and that allow me to use that tool in that holder. So I'm able to use 6 tools on this setup, and you can set it up if you want to machine all in one go, more or less automatic. You could, I suppose, even fit the air operated lever collet chuck. I've got a lever collet chuck on mine, which is hand operated. However, I don't anticipate doing huge quantities of stuff. This run is these are wheel nuts for vintage cars in 316 stainless. A run of approximately 60 of them. So far it's going pretty well, apart from you'll have heard me shout in the video that I have had a collision with the rear guard and bust a few bolts in it and bent the rear guard because the work was too long in the spindle and it was sticking out the back too far, and in the y-axis it got too close and it pushed its way through. But apart from that, everything's going fine with it. It's really going well. I had troubles parting off. I got round that by using flood coolant, and that's one of the reasons why I don't use in the settings. If you set it up for gang tooling, I think it's turret. If you set it up for turret, it won't prompt you to change tools. It'll just go straight ahead and it'll put in whatever you put in the program, and it'll go straight to that tool without being prompted. Now, fortunately or unfortunately, I don't use it because the coolant isn't on all the tools all the time. I like to stop and put the coolant on. I use mist coolant for all the external work, all the facing and profiling, and I use flood coolant only for the parting off. So I have to move the mist coolant around all the time, hence the reason for not using the turret tooling facility on it. If I wanted to, all I have to do is go into settings and press the turret and it would do it. I'll show you what I mean on the screen. If I come into settings, excuse me, up here you'll see gang tooling. If you click on that, that activates the gang tooling, and it will just sail through the program. And that's manual tool change is what I've got on there. So that's the reasoning for me stopping. As I say, it's just to reposition the coolant. Anyway, when I did the program in Fusion, it comes out assuming I don't know what for tooling, but between each, this is the first profiling part of the program, and then it goes on operation 2, which is the second part of the profiling, as you can see there. Tool 12, that's another thing that had me baffled. But tool 12, number 12, and you put it in as 1212. What you have to be careful of course, in this instance, is the Y position. Where is it? You know, etc. How do you tell it where it is? Well, I think if you go up the start of this, you will see. Now, this wasn't written into the program at first. The program that came out from Fusion 360, it read G90, G0, X45.4, and that was it. But I know that tool number 6, the centerline position for it is Y minus 15.054. So put that on there, and that immediately will move it across to that direction, and it will go to G30 first, and G30 is right away back here. So I know that it clears all the tools, so it goes to G30 first, and then the next operation will be to go to X45.4, which is well clear of the diameter, and 15 Y minus 15.054, which puts it bang on centre line for facing. And then the next one, I'll come down here. So as I say, this is quite a long bit. I go to operation 2, profiling, and again here, that's at the start, N212, and again, there you go. It came out with J0, X45.4 and Z5.4, and I knew the position was minus 38.77, so I was stuck in Y 38.77 in the editing part of the program. In other words, go into File and then Edit G code, and that's where I put it in. And you can see here, I've been playing around here, taking out some of the pecs. As you can see, PEC 10, But where's all the others? I decided not to go with pegging for the parting because it just wasn't going very well. As soon as I did that and got flood coolant on, I got good results. So I took out 9 previous steps and just altered that to suit. But anyway, let's go back here again. You're getting the idea. That was the two. Where are we? There we go. Too late. So that's the end. That's the end of the second profiling tool, and then we come on to centre drilling, which is done with tool number 8. And once again, you will find somewhere in here I've put a Y position. There it is. Y 101.551. So that's that one. And then tool 9 again. X Y 151.043. And the final one, which is this one, this is the tapping drill, and again you see there I stuck in the Y 152.816, and finally for the parting tool, the parting G code, I put in my Y of 62.978. So and once you've done that, that's more or less it. You know, it's going to follow that. Okay, it doesn't do it seamlessly. It probably would if I said gang tooling, but I want it to stop between each one and tell me to change tools, so I just leave it. I've left it on manual. If it had been on turret, it would have carried on and done. I believe it would have carried on without stopping. But I'm not that confident yet, but it's nearly there. Anyway, let's switch the machine on and we'll take it from there. Okay, let's cycle start. Here we go. Okay, you can see the first pass. In fact, the first couple of passes don't actually do much, which is doesn't really bother me that much. At least you can see what's happening there. It's a reasonable shot, and there's plenty of light on it. Okay, once it gets onto the next cut, you'll hear it start to maybe try to do some cutting. There we go. I like it reasonably slow, because if I take it at 100%, it's just a little bit too much. I could fiddle with the program, but when you've got the slider control there, why bother? Turn the feet down to what I want. And similarly with the parting, I can do the same sort of thing. So that's the first. For the next one, and that'll be a bit louder. There we go, you get the idea. And that's the roughing down of the outer diameter done up to the first shoulder. Just about. I might have one more cut to make, and we'll see. Yeah, and it's now starting to profile the nose. One thing I could have done instead of it asking me to change tools, I could have just put the machine on the settings onto turret and put optional stops at the start of each program, just so I had time to check out things before it went on to the next stage. There is one optional stop in there, and I think it's a leftover from something else that I popped onto the program, because this is a combination of the Fusion 360 program and also the parting I added on at the end using conversational. So it's a mixture of the two. I just added a small parting program to the end of this program. and it works fine. It's good, and it's what I like about this whole system. It's quite versatile. You can move around in it and alter things as you want. And you can see there the profile slowly taking shape. It is slow, I must admit, slower than I want it in some ways, and it could have higher RPM. There is a problem with my rapid turn at the moment. You might even see it here. Occasionally it skips a beat. Now that strikes me as being the motion sensor that's inside the machine. It detects the plate or the little pointer every time it comes past. Tarmac would say it's not close enough to it. I can assure you it's as close as I can get to it. So I think there is a slight problem with the sensor. Might invest in a new one just to see if it cures that, because it can cause big problems, especially when you're using small drills. And it also, with a big drill, it will stall out, or it'll trip the overload sort of thing, and you have to reset the axis, the Z axis, which is not very user friendly in some ways. But anyway, at least I know what's happening with the machine when it does it. It's a bit of a pain actually. I would like to be able to use it a bit, run things a bit faster, but at the moment I can't. So we'll have to put up with it. And there you see, that's the profile on the end, rough, and now it's going to do this part here now. So you've got this part roughed out, and we're just starting on this up to this shoulder. I think we're almost on the last of the cuts for that profile. Certainly not far off it. Yep, there we go, and now it's going along, and it's going to start to cut this part here, which these will be turned around at a later date to produce the domed end. You can see now at the back, I don't know if I'm getting any closer. No, that's it on full. You can see the profile is well on its way. What will happen is it will finish off that undercut, and then it will come back across to the nose, and it will do a couple of final passes right the way along the whole profile. So we'll see that when it happens. You may have noticed in some of my earlier videos that I have a guard, a protective guard over the nose of the rapid turn, made out of brass to protect the motor. Unfortunately, with this job, the travel in the Z direction is too great. It comes too close to the bellows on the vertical, on the head. I don't want to smash anything, so rather than take any risks, I've taken it off just for this job, and I've put that bit of shim plate there, shim stock. It's just keeping the coolant out of the motor, and it's really important when you put the flow coolant on because it goes everywhere. And there you go, you see why we've been talking. Just started the roughing pass. Go. That's more or less the first pass done, And now it goes along and does one more pass. I'll not bore you with that. Well, I will. When it's done this pass, it'll go and it'll face the nose up below. And that's it, almost finished the final pass of the first profiling operation. It's just going to face that nose off, and there you see it. Okay. Change that tool and hit the cycle starting. Didn't realise how close that was to the edge of the. That is. Now I know why I cut it too long. I'm going to have to be careful with that. In fact, it's not really done it any good at all. I didn't realise just how far back that travels, and in the position of these two tools, that this bar will probably clear on the other tool, which is about an inch further over in the y-axis, but this one it won't, and you can see there's a wobble on that now. It'll probably be okay. We'll see. Ah! Jesus! That was a disaster. I didn't check, or I didn't really think when I went on to select this tool how far back towards the Z-axis. Well, I did know it would go all the way virtually back to the end stop, because it's quite a long piece of work, and of course the end of the bar took the took that part of the back out here. It's popped one of the, well, two of the screws have been sheared, and it's bent at the back. You can't really see because this arm's in the way. There you go. Let's give me a better view of it if I can. You can see there, it's kind of made a mess of that, but I'll straighten that out. I've got plenty of big hammers around, sort that out. Fortunately, I don't think there's any other harm. I checked the axes and everything's okay. I'm going to have to tie this arm back here with all these tools on it until such times as I get that straightened out. As you can see, it's hanging down a bit. Well, the tool's just nearing the end of the first profiling operation. I don't know if you can see in there. See if I can get some more light in there. You can't really see a great deal. Oh, you can there, that's better. And there you see it's just at the end of it, this bit of the profile. It goes along to the end, faces the end off, and then it goes into the next. Now set the machine into gang tooling, so it will do everything seamlessly. I've also taken the MO1 brake off the program, so it should go through without any prompting. I will have to move the... Oh no, I don't need to move that just yet. For the next one, this is a rear cutting tool. You might be able to see it going in there. It's just squaring the shoulder up on the back of the thread, on the back of that hexagonal section. And when that's finished, it goes into the centre drill. And that's it. So I'll move the coolant across to here. Not that it really needs a great deal for the centre drill anyway. It does the program, does what I want it to do, and that's the main thing. And it's doing it fully from one end of the operation to the other. I'll try and get that to don't understand why you get nice twin spirals for the first 1 millimetre of travel, and then it goes over to 1 measly little strand, but never mind. I think it's probably just a low feed rate. It struggles. I sharpen the drill, but I wouldn't say it struggles, but it just, I wish it would do it a little bit better. 1 millimetre to go. Just get this so I can blow the cuttings off the end. That's fine. The plates are, this one's about 4 millimetres, then 3, and then 2, or thereabouts. And here we go, another bite finished. And another. And yet another. I think it's got another 2 passes after this. And then we'll go on to the hamming drill, and it should just about take up the first bit of feed any second now. There we go. And that's the first bite done. Second. Yep, and the next phase is parting off. Plenty of coolant, there you see the flood coolant. You need it for this. There it is. Now, there we go. Nice round curling cuttings coming off. Side curl, pretty good start cut. There. And now, just a bit of a rumble, there you can see it's starting to wobble, and it's on. Just past the centre. And that's it. That's the operation done fully automatically. Okay, well here we go with the domed ends. First operation, well it's only one operation, but basically it's shaving the end off, the excess from the end, and then creating the domed end. That's better, you can see what's happening now. There you see, just shaving the end off. About 0.5 millimetre at a time. Small cut. Not too much loosening. I think that's the last of the end cuts. Should be, I think. Yep, there we go. And here it starts the domed part of the cut. And that's that one done. We'll just take that out and put it in front of the camera so we can see it. Turn the coolant off. And there we see the domed end, hopefully. No, you can't. There it is there. It's out of focus. There you go. You can see it a bit better there. And it's a lovely finish. Slight pimple on the end there. Nothing much. In fact, it's not. It must have just been a speck of coolant or cutting. But as you can see, good finish on them. Excellent. Lovely job.